Lesson 18.1, Task 2. Solve simple quadratic equations. All right, to solve an equation, ax squared equals c. So we learned in the previous task that you can use square roots to solve quadratic equations of the form x squared equals c, where c is a perfect square. You can also use square roots to solve quadratic equations of the form ax squared minus c and ax squared equals c, where a and c are real numbers and a is not equal to 0. Suppose a goalie has left the right walls as shown. The goalie is roughly shaped as a parabola, where x represents the horizontal position in feet and h of x represents the vertical displacement in feet with respect to the top of the goalie. The corners are located at the x-intercepts and h of x as shown. How wide is the goalie? All right, so you can see the image right here, and you can see here is the parabola shape in the middle of the goalie, and you can see h of x is your y-axis. It's just in function notation, and then your horizontal is your x-axis as usual. So the x-axis is going to be the horizontal distance between the two x-intercepts, which is going to be the distance across the goalie. All right, so it says, what is the first step to solving the problem? So the first step is we're going to set y, or h of x, equal to 0. And then once we set it equal to 0, we're going to solve. All right, so complete the equation. Start with the result from part A to show steps to rewrite the equation in the form x squared equals c. All right, so h of x equals 0. So the first thing we're going to do is set, this is h of x. If you look up here, you'll see h of x equals this right here. So we're going to set that equal to 0. And then we're going to solve. So the first step would be to add 27 to the other side. So that means 1/3 x squared would equal 27. And then we multiply both sides by 3. Multiplying both sides by 3 is the same as multiplying by the reciprocal of 1/3. 3 over 1 is the reciprocal of 1/3. So 27 times 3 is 81. So that gets x squared by itself. All right, choose the correct numbers to complete the statement. The simplified solutions are, all right, so once you get to this step, we're going to take the square root of both sides. And remember, we're going to get the plus or minus of the square root of 81, which is plus or minus 9. All right, so that means the goalie is, all right, so how far is it from -9 to 9 on the x-axis? So you can see that you go 9 and then 9 more. So that would be a total of 18 feet wide. All right, so that's all for task 2. If you have any questions, let me know. Lesson 18.1, task 3. Solve ax squared equals c. Given that c is greater than or equal to 0, you can solve the equation x squared equals c by using square roots to get x equals negative square root of c or x equals positive square root of c. Suppose c is a positive real number but not the square root of a rational number. Complete the statements to describe the solutions. The equation x squared equals c, it will have real solutions, so it does have real solutions, and the solutions are rational, irrational, or imaginary. So you'll learn about imaginary numbers later, but these will be irrational numbers. So remember what an irrational number is. An irrational number is a number like pi, or a number that will not have a repeating decimal, cannot be turned into a fraction, and it does not have a terminating number. So it means non-terminating, which means it goes on, a decimal place goes on forever. So lots of times square roots will be that. So when we're going to look at some of these square root equations, you will see that some of them will have irrational answers. All right, so let's look at one example. How can you express the solutions x squared equals 5 exactly and approximately? Put the solutions into the correct placement. All right, so right here we're going to take the square root of both sides. So we're going to get the square root of plus or minus the square root of 5. All right, so those are the exact answers. And to get an approximate answer, you can find the decimal version of this and just round it. So if you want to know the square root of 5, what it's approximately equal to, just type it in. So the square root of 5 is going to be approximately equal to 2.2, which means negative square root of 5 would be negative 2.2. So these are called approximate answers because you can see the decimal went on and on. This is considered an irrational number, and we had to round this number. So when you round it, it becomes an approximate answer. So if it asks for an exact solution, you're going to leave it as a square root. If it asks for an approximate answer, rounding is okay. All right, so it says, what is the solutions of the literal equation, ax squared equals c? All right, literal equation just means it's a formula with the variables. So you still solve it the same way. You're just not going to have numbers in it this time. So what we're doing is solving for x. You can see all these are set equal to x. So we have ax squared equals c. And to get x by itself, we're first going to divide by a. So we're going to have x squared equals c over a. And then we're going to take the square root of both sides. And when we do that, remember you get a plus or minus. Square root cancels the squared term here. So x equals plus or minus the square root of c over a. All right, so the answer for this would be the last one. All right, so it says use the general solution you wrote in part C to put the answers into the table as instructed. Place the exact solution of 3x squared equals 6 in the first space below and the approximate solution in the space at the bottom. All right, so we're going to solve these, and we need an exact solution and an approximate solution. So we're going to have 3x squared equals 6. First thing we're going to do is divide by 3. X squared equals 6 divided by 3 is 2. I'm going to take the square root of both sides. X equals plus or minus square root of 2. So that's going to be my exact solution, plus or minus the square root of 2. And if I want to know an approximate solution, I'm going to say what is the square root of 2? And it's about 1.41. So that's going to be my approximate answers here in the second box. All right, so the next one here is going to be negative 4x squared equals negative 5. Divide both sides by negative 4. X squared equals, two negatives make this a positive, so 5 over 4. I'm just getting rid of the negatives right now because two negatives make a positive. So I'm going to do square root. So I'm going to plus or minus the square root of 5 over 4. So x equals plus or minus the square root of 5 divided by the square root of 4 equals 2. All right. So that would be, this is my exact answer. All right, and my approximate answer, I'm going to do the square root of 5, and then I'm going to divide that by 2. So that's going to be about 1.1. So here again is my exact answer, and here is an approximate answer. And sometimes they'll ask for an exact answer and sometimes an approximate. All right, solving the equation 2x squared equals 1 gives plus or minus the square root of 1 over 2 equals plus or minus the square root of 1 is just 1, but then you're left with the square root of 2. To avoid having a square root in the denominator, you can multiply both the numerator and denominator by square root of 2 to rationalize your denominator. So here's what that looks like. So if we have 2x squared equals 1, and we solve this, we're first going to divide by 2. We have x squared equals, getting ahead of myself here, plus or minus equals 1/2. And then we're going to take the square root. When we take the square root, we have plus or minus. X squared and square root cancel, so x equals plus or minus. Again, the square root of 1 is just 1. The square root of 2 is an irrational number, so it stays the square root. But they want us to rationalize the denominator. So it says you can multiply the numerator and denominator by this number. And what happens then? Now I have the square root of something squared, which means that's going to cancel my square root. So I'm going to have plus or minus. On top, I've got 1 times the square root of 2, which is just square root of 2. And on the bottom, I have the square root of 2 squared. Square root of 2 squared means the square root cancels and leaves just 2. So x equals plus or minus square root of 2 over 2. All right, so the result of this calculation is the square root of 2 over 2. This step is called rationalizing the denominator because it converts the denominator to a rational number. 2 is a rational number. So we took this irrational number, multiplied by itself, so we squared it, and that made it a rational number. And that is called rationalizing the denominator. And that's something you will be asked to do often as well. All right, that's all for task 3. If you have any questions, let me know.